So let's start off with the next type of integration, and this is integral of the form. So you have integral sign, and in the denominator you'll have a quadratic equation of the form ax square plus bx plus c. However, in the numerator you'll have a linear equation, that is, let's say, px plus q. So this is integral of this form, or you'll have in the denominator you'll again have a quadratic, but this time inside a root. So you have square root of ax square plus bx plus c. In the numerator you have px plus q dx. So let's try the sums based on this. And before we try those sums, let's write the steps by which you can solve this question. So let's see the steps to solve these particular type of questions. So step one, what you do is the linear equation which you have in the numerator, you equate this to equal to, you do this equal to a into derivative of the quadratic, that is ax square plus bx plus c plus b. So once you do it, you'll get the value of a and b. Okay. So step 2 is find a and b by equating both sides, which we'll see in the examples how we can go about doing it. And the third step is you replace the linear equation px plus q by this part, because now you'll know a and b, so you can replace it. Okay, and then we can go ahead and solve the question. So let's start off with the sums. So let's start off with the first one. So let's say you have integral of 5x minus 1 upon 3x square plus x plus 2 dx. So the step 1 is linear equation. So linear equation minus 1 is equal to a into derivative. So derivative of the quadratic is 6x plus 1 plus b. Now let's equate. So when we equate, we get 5x minus 1 is equal to, so see the x term is 6a x plus a plus b. So now see, we can equate this. So the x term and the constant terms. So what we get is 5 is equal to 6a. So a is equal to 5 by 6. We got the value of a. Now let's find the value of b. So minus 1 is equal to a plus b. A we know, we'll put the value of a and we'll get the value of b. So this you can solve. We'll get b as minus 11 by 6. Once you get the value of a and b, now the step 3 in this integral, instead of this 5x minus 1, what I'll write is, I'll write a, that is 5 by 6 into 6x plus 1, and then plus b. So b is minus 11 by 6 upon 3x square plus x plus 2 integral sign dx. Now the reason we have done this is, see, now we can separate these two parts. We can separate this. So just see how we'll do it. See, we'll separate this in the V shape. We'll separate this. So we'll have this part will be, see, it will be integration 5 by 6 6x plus 1 upon 3x square plus x plus 2 dx, and this part will be, let's take minus 11 by 6 outside, 1 upon 3x square plus x plus 2 dx. Now can you identify this part? See, this is the last lecture which we have done, 1 upon quadratic type. Now this part we can solve separately, and this is what, this is derivative of the denominator is in the numerator. So this part will become 5 by 6, and whenever you have the derivative of the denominator in the numerator, you can write ln of the denominator. So ln 3x square plus x plus 2, and this part you can, 5 by 6 will be still there, right? Because 5 by 6 was not part of the derivative, right? So 5 by 6 ln 3x square plus x plus 2, And this part now you can solve, looking at the last lecture, we have done quite a few sums based on this. So I'll write the final answer. You can solve it and see if you remember that type where we used to convert it into perfect square. So if you solve this, the answer you will get as minus 11 2 root of 23 tan inverse 6x plus 1 upon root 23 plus c. So you can solve this, and in case you have any doubts getting this answer, then you can write in the comments. Okay, let's try one more where you have a square root. So let's say now I have a question which says integration 2x plus 1 upon square root of x square plus 2x plus 3 dx. So again, step 1, numerator is equal to a into derivative of quadratic, right? Only this part, not the square root. So that is 2x plus 2 plus p. Now you equate, so you have 2x plus 1 is equal to 2a x plus 2a plus b. So 2 is equal to 2a, so we get a as 1, and you get 1 is equal to 2a plus b. So a we know is 1, so b will be minus 1. We got the value of a and b. Now what we do is, in the integration, instead of 2x plus 1, what we'll write? We'll write 2x plus 2 minus 1 upon, right? So a is 1 and b is minus 1 upon square root of x square plus 2x plus 3. Now again the same thing, you just separate this. So what you'll have is 2x plus 2 upon square root of x square plus 2x plus 3 dx minus integration 1 upon square root of x square plus 2x plus 3. Now if you remember, this is again the same thing where derivative of this is in the numerator. However, this is in root. So in this case, the answer in this case would be 2 root x square plus 2x plus 3, right? Minus, and this is as per the last part which we had done in the last lecture, 1 upon square root of quadratic. You can solve this, and you will, by completing the squares, and the answer you will get is minus log x plus 1 plus square root of x square plus 2x plus 3 plus c. So again, you can try solving these two sums, and you can see, in case you are getting some problem for getting the final answer, you can just write down in the comments and I'll solve that part also. Okay, so hope you enjoyed this video. Till next time, take care. Bye bye.